Hello everyone! Today we are working on some parallel line and perpendicular line drawings. In these problems you will see a line, and on these first couple of problems we're going to be drawing a parallel line that goes through a point. So a parallel line that goes through a point. And then towards the end of this video we're going to be doing ones that are perpendicular. So just in case you've forgotten, parallel lines are lines that do not intersect. They are inside of the same plane, meaning they're on a piece of paper basically, as opposed to like three-dimensional figures, and they do not intersect. They are parallel, whereas perpendicular are ones that cross at exactly 90 degrees. So this is perpendicular, and this is parallel, like so. So, I don't know, this has nothing to do with what we're doing today, but just as a reminder, there are symbols to represent perpendicular and parallel. Whenever you're talking about like line L and N or line P or Q, the symbol for perpendicular is this upside down T, and the symbol for parallel is literally just two slashes, because two slashes together look like parallel lines. So those are symbols, but we're not working with them today, but I just thought I'd talk about it in case it comes up later. So in here in geometry, the reason I start talking about slope is because whenever you have two lines that are parallel, they're going to have the exact same slope. It should make sense if you remember that slope is rise over run. So if this goes up and over that amount, this one should also go up and over that amount to make a line. And that's what I'm going to do. I'm going to go from here and I'm going to count how much the slope is. So it's 1, 2, 3, 4. 1, 2, 3, 4. Yep, that is 4. And then over 1, 2, 3, 4, 5, 6. So up 4 and over 6. That is the slope, and that's just exactly what I would do for this point in order to make the line. But as you can see, going up 4 and over 6 is going to be off the chart. So I'm just going to do it backwards, as if I started at this point and went over 6, down 4. So I'll go over 6 and down 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So these 2 points are going to be a line that is parallel. So I'm just going to kind of use my sheet of paper, I guess, to make a line that's straight. I'm bad at drawing, so I like doing that. And there you go. That is a parallel, and sure enough, it looks parallel. Up 4 and over 6, up 4 and over 6, same slope. I did say it, up 4 and over 6, so the rise over run is 4 over 6, which simplifies to 2/3. So the slope is 2/3, and the other slope would also be 2/3, which, technically means I could have gone up 2 and over 3 and got a point. Up 2 and over 3, up 2 and over 3, up 2 and over 3. But it's not necessary, it's just cool. Like math is cool. For this one, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So up 8, then over 2, up 8 and over 2. And I would do the same thing for this one. 1, 2, 3, 4, 5, 6, 7, 8, over 2. Up 8 and over 2. Like that. And then you would connect these into a line. So maybe you can freehand it, but I can't. So I'm terrible at drawing, so I'm just going to fold the page over a little bit to make a line that's straighter. Do make sure when you're writing the slope you do simplify. 8 over 2 does simplify. I've had people write 4 over 1, and that is technically true, because if you divide them by 2 you get that. But please make sure you do simplify completely. 4 over 1 is equal to 4, so your answer should be just 4, not 4 over 1. Okay, just wanted to mention that. So there's a couple more problems here. I'm going to zoom out a little bit. What I recommend is for you to, I don't know if you can copy this onto a separate sheet of paper and try it, but at least visualize where your point should be. Like pause it, visualize where the point should be, then unpause it and see if it's where it should have been. So take that. Pause it now, see if you can do number 3 where the point should be, and then I'll do it. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So if you chose that point, then you got it correct. Those are the 2 points that we need in order to make the line. So if you chose this one, you got it correct. So go ahead, same thing here. Pause it, see if you can get that one right. So 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. So up 2 and over 8, up 2, then go over 8, then go over 8, like that. So if you chose that point, you got it correct. And then, we just connect those lines. So I'll do that real quick. Connect those points to make a line, my bad. This one was over here. Okay. There you go. So that's those 2. And I'll just, yeah, okay. So same thing here, up 2 over 1, up 2 over 1. Make a line, I'm just gonna freehand it this time. This one, oh boy, I don't see a second point, but it does look like it goes through this. So down 2 over 2, down 2 over 2. Ugh, see, that's why I always fold it over, because that does not look parallel. Ugh. Oh well, I got my 2 points, right? I'm not writing what the slopes are. I'm just going to come back and do that later. And then there's 2 other problems right there. So same thing, I would just pause, see if you can do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. Like so. Okay, sweet. Next on to perpendicular. With perpendicular, it is something called opposite reciprocals. And when I say I'm opposite, I'm talking about positive versus negative. When you have the slope, let's just pretend it's 7. If it's 7, then the opposite would be a negative 7. Or if it was negative 3, the opposite would be positive 3. So whenever you have the slope, like here, it's a positive slope. It's going uphill, so it's a positive. That means the perpendicular is going to be negative. It's going to go downhill. And if it's already negative, so like this one's going downhill, then the perpendicular is going to be going uphill. It's going to be positive. So whatever slope you start with, switch whether it's positive or negative, and that's the opposite. When it comes to reciprocal, that is when you switch the numerator and denominator, right? Numerator and denominator. Switch. Also known as flipping the fraction upside down. For example of reciprocal, if you have 1 over 3, the reciprocal is 3 over 1. You switch them. If I had 5 over 2, then it would be 2 over 5. Those are the reciprocals. And if you have something like a whole number like 4, then the reciprocal would be 1 over 4, because technically a 4 is over 1. So that is reciprocals, what they look like. The 1 over 3 is 3 over 1. 5 over 2, 2 over 5. The 1 and the 4, etc. And like I said, like if I wanted to put this full circle together, if it's opposite, then if this one was a negative 1/3, then this would have to be a positive. If this was a positive 5/2, then this would be a negative 2/5. But no matter what, one of them has to be negative and one of them has to be positive. So like if this was positive, that one would be negative. But no matter what, every single time, one of them is positive, one of them is negative, and the others are just flipped upside down. So in this case, you do actually have to find the slopes first. So here we go. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So the rise is 4, the run is 6, which simplifies to 2/3. So since this is 2/3, the opposite would be a negative. Instead of a positive 2/3, it'd be a negative. And instead of 2 over 3, it'd be 3 over 2. So here is the perpendicular slope. Because remember, that's similar for perpendicular. So the 2 over 3 is 3 over 2. This was positive, so I make it negative. So from this point, I'll go down 3 and over 2. 1, 2, 3, 1, 2. To get those 2 points. And I'll connect these like that. And you know, it should definitely look like a right angle. Like if I just turn the page, you can see this is definitely a right angle. It looks like it's correct. So that's always a good thing to do. See if you can, well, I can tilt a paper, but if you're on a computer screen or something, you might have to tilt your head. It's like, oh, well, okay, yeah, that looks like it's a right angle, you know. So, whoop, let's go ahead and refocus. Boom. Another example, this one up here, I'll count rise over run, right? Rise over run. 1, 2, 3, 4, 5. 6, 7, 8. So the rise is 8, and the run is 2, which is equal to 4 over 1, which you know is equal to 4. I'm going to keep it as 4 over 1 simply because, you know, I'm not looking for the number 4. I'm looking for the opposite reciprocal. So this is positive. I'll change it to negative. This is 4 over 1, so I'll make it 1 over 4. And that is the perpendicular slope. So from here, I'll go down 1 and over 1, 2, 3, 4, like that. Once again, you know, it looks perpendicular. Maybe not perfectly perpendicular this time because I didn't go straight through this point. I was a little bit up, but, you know, it's believable. Number 3 is a good example because this time it's finally starting going downhill. It's a negative slope. So here we go. 1, 2, 3, 4, 5, 6. So I'm going down 6 and over 1, 2, 3, 4. I'll double check that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah, so down 6 and over 4, which simplifies to negative 3 over 2. And this time, since it's already negative, my answer is going to be a positive. So negative, change it to positive. 3 over 2. Reciprocal is 2 over 3. Opposite, reciprocal. The way I remember is that it's 2 words long, so you're going to do 2 different things. Opposite, positive, negative. Reciprocal, flip it upside down. You never just do one of those, because some of the questions you get are these parallel slopes or are these perpendicular slopes? And the way you check is to see if it was opposite and a reciprocal. Not just one of them, but both of them. So a positive 2/3 is our perpendicular. So positive 2/3, positive 2/3. So that's another point. And, you know, I have space, so I'm going to do it again. Up 2 over 3, up 2, and over 3. Just to get 3 points, to make it a little more straight. Kind of messed it up anyways, but oh well. That's the perpendicular. So once again, this does look perpendicular. It's a little better this time because I did 3 points instead of 2. But, okay, that's it for the lesson part. I'll quickly do the rest of them. Just the same thing as before. I would see if you can picture where the point should be. But I'm going to do the next kind of quickly because I already done explanations. So just pause it each time and see if you can see where the point is supposed to be. Okay, here we go. 2 over 1, 2, 3, 4, 5, 6, 7, 8, which is 1/4, so negative 4 over 1, so negative 4, but whatever. So 1, 2, 3, 4 over 1. Down 2 over 1, so that's negative. This will be a positive 1 over 2. So up 1 over 2. This is 1, 2, 3, down 3. 1, 2, 3 over 3. So negative 3 over 3. That's negative, so I'll change it positive. 3 over 3 is just going to be 3 over 3 again, which does simplify to 1 over 1, or 1. So the slope is 1. The perpendicular is going to be, negative 1. So the perpendicular would be 1. So up 1 over 1. Or you can do the up 3 over 3. It doesn't matter. Either way, you get this line right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whew. Down 9 and over 1. So negative will now become positive. 9 over 1 is 1 over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 1, 2, 3, 4, 5, 6. Rise over run equals 1 over 3. This is positive, so I'll make it negative. 1 over 3 is now 3 over 1. So down 3 and over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And I'm a little bit off the page, my bad. I was caught up in the moment. As you can see, these all look like right angles, so they're good. All right, they look like right angles. Okay, that's it. Zoom out if you guys want to look at the whole thing together. There you go. Hopefully this is helpful. See you next time.